Hello viewers, in today's class we are going to discuss a very important problem from probability distribution, right? So now we have already discussed the concept of probability distribution in our earlier videos, and we have also solved some important problems related to probability distribution, right? So in this class we are going to solve yet another problem from probability distribution, right? So let us start. Now here we have the problem that a bag contains 4 white balls and 6 red balls, right? And 4 balls are drawn at random from the bag, and we have to find the probability distribution of the number of white balls. So now here we have a bag, and this bag contains 4 white balls and 6 red balls, right? And we have to draw 4 balls at random from this bag, right? Okay, so now here we have to find the probability distribution. So therefore we have to introduce the random variable that is x, right? So the random variable is denoted by the letter x, and we have to assign values to this random variable x, right? Now here we have to find the probability distribution of number of white balls, right? Since here we have 4 white balls and we have to draw 4 balls from the bag, right? So this x can take values 0, 1, 2, 3 and 4, right? So actually here the random variable x denotes the number of white balls drawn, right? So here we have to draw 4 balls, right? So when we draw 4 balls from the bag, then we may have none of the balls are white. So when none of the balls are white out of 4 balls, then x will take 0 value, right? And when x takes 1, the value 1, it means we have 1 white ball and 3 red balls, right? And similarly when x takes 2, the value 2, then it shows that we have 2 white balls and 2 red balls. And when x is 3, then it shows that we have 3 white balls and 1 red ball. And when x is equal to 4, then it shows that we have all the balls as white, right? So x is equal to 0, it implies none of the balls are white, right? Because if we draw 4 balls and all the 4 balls are red in color, so x is equal to 0 implies no white ball, right? Okay, when x is 1, it implies that we have 1 white ball and 3 red balls, right? And when x is 2, then it implies that we have, out of these 4 balls, we have 2 white balls and 2 red balls. When x is 3, then we have 3 white balls and 1 red ball, right? And when x is 4, it means we have all the 4 balls as white in color, right? So here we have 0 red balls, or there is no need to write this 0. So we have all the 4 balls as white, right? So let us read this question once again. A bag contains 4 white balls and 6 red balls, right? And we have to draw 4 balls at random from the bag, and we have to find the probability distribution of the number of white balls, right? So we have introduced the random variable x, and this x can take the values 0, 1, 2, 3 and 4, right? So x is equal to 0 implies no white balls, right? And here all the 4 balls are red in color, and when x is 1 we have 1 white and 3 red balls, and when x is 2 then we have 2 white balls and 2 red balls. When x is 3 we have 3 white balls and 1 red ball, and when x is 4 we have all the 4 balls as white, right? Okay, so now here we have to find the probability of obtaining the white balls, right, in all these 5 cases, right? So now we have to find p of 0, or we can also write it as p of x is equal to 0, right? So p of x is equal to 0, it means the none of the balls is white ball, right? It means all the balls are red in color, so all balls are red, right? So now when all the balls are red, it means we have to select, see here we have to draw 4 balls, right? So when all the balls are in red in color, so it means we have to draw 4 balls out of 6 red balls. So the number of ways would be 6c4, and the total number of cases would be here the total number of balls are 10. So we have to select 4 balls out of 10 balls, right? So the number of favorable cases when all the balls are red in color, so this is 6c4, and the total number of cases would be 10c4, right? Okay, now when x is 1, it means we have to find p of 1, right? And p of 1 is p of x is equal to 1, right? And p of x is equal to 1, it shows that we have to find the probability of getting one white and 3 red balls, right? So 4 balls are to be drawn, and out of these 4 balls we have 1 white and 3 red, right? So 1 white ball can be selected, or it can be obtained by 4c1 ways, right? Because we have 4 white balls and we have to select 1 ball as white, and 3 red balls can be selected from 6 red balls in 6c3 ways, right? And we have to multiply it, so the total number of favorable cases would be 4c1 times 6c3, and the total number of cases would be 10c4, right? Okay, now let us take x is equal to 2. So p of 2, it implies that p of x is equal to 2, right? So p of x is equal to 2 implies that we have to find the probability of getting 2 white and 2 red balls, right? So the total balls are 4, and we have to draw 4 balls at random from the bag. So 2 white balls can be selected out of 4 in 4c2 ways, and 2 red balls can be selected out of 6 red balls in 6c2 ways, right? And the total number of favorable cases would be 4c2 times 6c2, and the total number of cases would be 10c4. So here 10c4 implies that we have to draw 4 balls out of 10 balls. So the total number of ways would be 10c4, right? Okay, now for x is equal to 3, we have here p of 3, and it shows that this is p of x is equal to 3, and P of x is equal to 3, it implies that we have to draw 3 white and 1 red ball, right? And 3 white balls out of 4 white balls can be selected in 4C3 ways, and 1 red ball out of 6 red balls can be selected in 6C1 ways, right? And the total number of favorable cases would be 4C3 times 6C1 divided by 10C4, right? And P of x equal to 4, that is P of 4, that is P of x is equal to 4. It implies that all the 4 balls which we have drawn are white in color. So all the balls are white, and when all the balls are white, it means we have to select 4 white balls out of 4. So we have the total number of cases as 4C4 favorable cases, and the total number of cases would be 10C4, right? So viewers, what we have done here, we have introduced the random variable. We have assigned the values 0, 1, 2, 3, 4 because a maximum of 4 balls are to be drawn from the bag, right? And we have obtained the probability corresponding to 0, 1, 2, 3 and 4, and 0, 1, 2, 3, 4 denotes the total number of white balls which are drawn, right? So this is the situation, and now we have to solve these 5 quantities, that is 6C4 over 10C4, then this one, then this one, and then this one, and then this one, right? So here what we will do, will use the formula for the combination, that is NCR. So NCR is n factorial over r factorial and n minus r factorial, right? So now let us solve these quantities one by one. So 6C4 is 6 factorial over 4 factorial, and 6 minus 4 is 2 factorial, and this is 6 times 5, and here 4 factorial get cancelled. We have 2, and this is 2 3s are 6, and this is 15, right? And then 10C4 is 10 factorial divided by 4 factorial. 10 minus 4 is 6 factorial, right? And 10 factorial can be written as 10 times 9 times 8 times 7 over 6 factorial get cancelled, and 4 factorial is 4 times 3 times 2 times 1, right? So 4 2s are 8, 8 and 8 get cancelled. Here we have 3 3s are 9, so we have 10 3s are 30 times 7, that is 210, right? Okay, and now 4C1 is simply 4, and 6C3 is 6 factorial over 3 factorial and 3 factorial. 6 minus 3 is 3 factorial. So we have 6 times 5 times 4, and 3 factorial get cancelled, and this 3 factorial is 6, and 6 and 6 get cancelled, so we have 20, right? And 4C4 is simply 1 because 4 factorial over 4 factorial, and 4 minus 4 is 0 factorial, so this is simply 1, right? And 6C1 is simply equal to 6, and 4C3 is equal to 4 factorial over 3 factorial. 4 minus 3 is 1 factorial, so here we have 4, right? So this is how we solved these quantities, that is NCR. So now viewers, here we'll substitute the values. So 6C4 is 15, and this is 15 divided by 10C4. 10C4 is 210, and here 4C1 is simply 4 times 6C3 is 20, and divided by 10C4, so this is 210, right? And P of 2 is 4C2. 4C2 is here we have calculated. Okay, so the value of 4C2 is 4 factorial divided by 2 factorial, and 4 minus 2 is 2 factorial. So here this is 4 3s are 12, 2s are 24, and here we have 4, so this is 6, right? So here we have 6 times 6C2, and 6C2 can also be calculated as 6 factorial over 2 factorial and 4 factorial. So this is 6 5s are 30 over 2, that is 15, right? So here we have 15, and 10C4 is 210, right? And P of 3 is 4C3. Here 4C3 is 4. 6C1 is equal to 6, and divided by 210, and 4C4 is equal to 1, and 10C4 is 210, right? So now 15 over 210 is equal to 1 over 14. We can simplify it, and P of 1 is equal to 8 over 21, and P of 2 is equal to 6 over 14, and here P of 3 is equal to 4 over 35, and P of 4 is equal to 1 over 210. So now we can write the probability distribution table, and the probability distribution table can be written like this. So here we have X, and here we have the corresponding probability, right? So the first row denotes the value of X, which is the random variable, and the second row denotes the probability corresponding to the value of the random variable. And here we have 5 values, and X has the values 0, 1, 2, 3 and 4, right? And the probabilities corresponding to X is equal to 0 is 1 over 14. So here we have 1 over 14, and the probability corresponding to X is equal to 1 is 8 over 21, and the probability corresponding to X is equal to 2 is 6 over 14, which can also be written as 2 3s are, this is 2 7s are, right? So either we can write 6 over 14 or 3 over 7. So here we'll prefer 6 over 14, and P of 3, which is the probability corresponding to X is equal to 3, is 4 over 35, and for X is equal to 4, P of 4 is 1 over 210, right? So this is the required probability distribution of the number of white balls when we have 4 white balls and 6 red balls, and we have to draw 4 balls at random from the bag. So now viewers, let us find out the mean of this probability distribution, right? So the mean of probability distribution is denoted by E of x. Here E denotes the expectation value of the random variable, right? Or this is also known as the mathematical expectation of x, right? So expectation of x is also known as mean of the probability distribution, and E of x is given by the rule or the formula, that is sigma of x p of x, right? So here we can also write sigma of x px as x1 px1 plus x2 px2 plus x3 p of x3. Then we have x4 p of x4 plus x5 p of x5, right? So this sigma of x px is equal to this expression, and x1 is 0, x2 is 1, x3 is x1 is 0, x2 is 1, x3 is 2, x4 is 3, and x5 is 4, right? And px1 is the corresponding probability, right? So now we can write 0 times 1 over 14 plus 1 times 8 over 21 plus 2 times 6 over 14 plus 3 times 4 over 35 plus 4 times 1 over 210, right? And now we have to simplify this expression. So this term is 0. We have 8 over 21 plus 12 over 14 plus here we have 12 over 35 plus 4 over 210. So now the LCM of 21, 14, 35 and 210 is equal to 210, and now we have 21 divided by 210, so we have 10 times 8, 80. Then we have 14, 15s are 210, so 15 times 12 is 180. So here we have 35, 6 are 210, so we have 6 times 12, that is 72, plus here we have 4, right? And if we add all these numbers, we'll get, so we get 336 over 210, right? So the sum of these numbers is 336 over 210, and now we can simplify this fraction, and we'll get here we'll have 370, and here we have 11 and 2, and then we have 35, and here we have 56, and we have 7 5s are 7 8s are, right? So here we have 8 over 5, right? So the expectation value of the random variable x in this case is 8 over 5, and which can also be written as 1.6, right? So viewers, this is how we solve this problem.